Hi and welcome back. In today's video, we'll show you how to apply statistics concepts such as probability to Python code. As a showcase, we'll use the statistics interview question from Goldman Sachs. But before we do that, if you want to learn more about data science, hit the subscribe button. Here's a question by Goldman Sachs that we will use to show you the binomial probability calculation in Python. The question wants us to calculate the probability of getting an even number of heads when 21 unbiased coins are flipped. So as an output, we will have a number between 0 and 1, which shows the probability of this question. To solve this question, you'll need to understand the concept of binomial distribution. The binomial distribution is a statistical method used to calculate the probability of a particular number of binary outcomes in a series of independent events. It is used when there are only two possible outcomes, like heads or tails, and the probability of success is the same for each trial. In our example, when flipping a coin, the binomial distribution can be used to calculate the probability of getting a certain number of heads or tails. Now we will cover multiple calculation options for coin flip prediction. First, let's look at the formula and the variables inside it. It will help you understand the logic behind the scene. So in this formula, P of x equals k equals nck, which can also be represented this way, times lowercase p raised to the kth power, times 1 minus lowercase p raised to the n minus kth power. Here, x is a random variable representing the number of successes, which is the number of heads obtained from the coin flips. K represents an even number of heads that we want to obtain from the 21 coin flips according to the question. N is the number of trials or the number of coin flips, which is 21 in our case. Lowercase p, the probability of success in each trial, which according to the question is the probability of getting heads from a coin flip. That happens to be 0.5 in our case. nck is the binomial coefficient representing the number of ways to choose k successes out of n trials. In our example, we want to find the number of ways to get an even number of heads from 21 coin flips, which can be calculated using the binomial coefficient as follows. By plugging these values into the binomial probability formula, we can calculate the probability of obtaining an even number of heads from the 21 coin flips. Let's calculate the first two possibilities. The chance of getting 0 heads is calculated like this. So the answer is just a scientific notation of 4.76837 times 10 raised to the power minus 7. Then the chances of getting 2 heads are 0.000100 and so on. We can then sum up the probabilities of all possible values of k that satisfy the condition of interest, which is even number of successes of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. To go on and obtain the probability of that condition occurring in the given number of trials. Okay, now it's time to calculate the binomial probability. We'll first do it using the math library. This code calculates the probability of getting an even number of heads in a coin flipping experiment of 21 coins. It does so by looping through even numbers from 0 to 21. For each even number, it calculates the probability of getting that many heads using the binomial probability formula. In the first loop, the variable I, so the range of start equals 0, stop 22, step 2 generates a range of even numbers from 0 to 21. The math.com function calculates the number of ways to choose I heads out of 21 coin flips. And 1 by 2 raised to the power 21 calculates the probability of getting I heads. The two values m and n are then multiplied to get the probability. This is the probability of getting exactly I heads. The resulting probability for each even number of heads is stored in a list of probabilities. Then we will loop over the probabilities and print the probability of getting each even number using the enumerate function. In the final step, we calculate the total probability. So here's the code, and now let's run that. Here's the answer. The probability of getting even number of heads is 0.5, which is 50%. Now we will do the same calculation by using a pre-built function in SciPy. There are several options to perform binomial distribution calculations in Python, but using the binom function in the SciPy stats module is a popular and widely used option. One alternative option is to use the NumPy model to create an array of possible outcomes and then use the binomial probability mass function to calculate the probabilities of each outcome. Another option is to use the math module to calculate the binomial coefficient and then manually calculate the probabilities for each outcome using the formula for the binomial distribution as we did earlier. However, these options can be more time-consuming and less efficient compared to using the binom function in SciPy stats. So here's the code for that. Now let's run that. Well, the first calculation is based on the formula for probability mass function of a binomial distribution, which we explained earlier. In this case, the calculation is done for all even numbers of heads from 0 to 20. The probabilities are then summed up to get the total probability of getting an even number of heads in 21 coin flips. The second calculation uses the binomial PMF function. It calculates the probability mass function for a binomial distribution. The probabilities for all even numbers of heads from 0 to 20 are calculated using this function and then summed up to get the total probability. The difference in the results between the two calculations is during the floating point precision error in the second calculation. In the first answer, the sum of probabilities is slightly off due to the limited precision of floating point numbers in computer programming. Generally, in computer programming, floating point numbers are represented in a limited number of bits, which can cause a loss of precision when performing calculations. That is why we're getting a slightly larger value in the second calculation. Now, the takeaway here is that if you work on longer scripts and plan to make longer calculations, plus you have limited computational power, work with SciPy, which is more efficient and faster. Yes, if you have enough resources, I would recommend the first calculation where we used math. This is if you want to be sure about the results, even if these slight differences make little difference to you. And there you go. In this video, we walked through the probability question from Goldman Sachs that required a step-by-step approach to find the probability of getting an even number of heads out of 21 coin flips. We also explored why the final probability calculation resulted in slightly different value due to floating point precision errors. This approach and the explanation can be helpful in tackling similar probability questions in interviews or on the job. If you want to learn more about data science and improve your problem-solving skills, be sure to subscribe to us for more insightful videos. Thanks for watching, and we hope to see you again.